Welcome to this week's lab. And this lab is going to start off with using an internet-based simulator, and then we're going to proceed to using these samples. So let's get started with the lab itself. It's going to take you to this little simulator, and there's a lot of different features of this simulator. Um, the first one I want to talk about is the chemical composition, and you can move the chemical composition up and down and change the rocks. In your lab two on plate tectonics, you mentioned if you looked at the rock samples, they gave you different names of rocks, like granite and basalt. Those were two common samples that you saw over and over again. You're going to see them in this example as well. Um, I do want to talk about the words felsic and mafic and then ultramafic. Ultra means beyond. And so mafic is a pseudo acronym for magnesium and iron rich samples. It does contain some silica. As you can see, silica is made up of silicon and oxygen. And the words felsic is also another pseudo acronym. It means feldspars and silica rich samples. And you know the mineral, last week we looked at the mineral quartz, and quartz is silicon and oxygen. It's really, really a common ingredient in the Earth's crust. And so rocks that are really rich in silica and oxygen are felsic. So in the simulator, you can adjust the chemical composition, and you can use the words felsic. There's a term called andesitic or intermediate, which would be in somewhere in this region. Then we have mafic, and then finally ultramafic. Now, to show the most extreme differences, we're going to use the words ultramafic and felsic in the simulator. And so you can see those two different simulation differences, and you can see what happens with the chemical concentrations. The cooling rate, we're going to look at either fast or slow, and there are some numbers in here, how fast it cools down, whether it be 1 degree Celsius a month, and if I can cool it down to 10 degrees every second, all the way down to 1 degree every 1,000 years. So lots of different variation in our samples. And then I always recommend we can shorten up the simulator. And so this is going to speed up the entire simulation to be a 1 minute time period. If you want to see this again at a slower rate, maybe see some of the things develop, you can switch it to the longer. But be aware that if you have it on the longer, it's going to take 10 minutes to complete the simulator. And so you'll be doing the simulator multiple times. So I would recommend doing the shorter version. We've got the temperature down here and how long these things are taking place. And then you're going to hit play. And with the concentrations and the chemical composition and the cooling rate listed, you're going to see different atoms moving around. And when those atoms are cooling off, they're going to form these different minerals. And again, we can use the key to figure out what minerals they are. And when we do this, we're going to see some differences. We've got the words olivine, olive green mineral, pyroxene, biotite, amphibole. You looked at an amphibole named hornblende in our last week's lab. We've got different types of feldspar, potassium feldspar, or plagioclase feldspar, sometimes, which is a sodium-rich feldspar. Muscovite, that really breaks into flat book-like sheets. And then finally, the one that we're going to be very familiar with is a sample called quartz. And you're going to run the simulator and kind of report what's happening and take some screenshots along the way for the first part of the lab. The second part of the lab is going to be using samples 1 through 12. 1 through 12. Anything after that are going to be used in a future lab dealing with sedimentary and metamorphic rocks. And so you're going to be answering the samples, answering about these different samples, and using your knowledge from the little simulator, you're going to see which samples are rich in iron, which ones are cooling fast or slow. And you're going to be reporting all that information. So you're going to be applying what you're learning using in the second part of the lab based on those simulators from the first part of the lab. If you have any questions about this, make sure you upload this image, upload this assignment into my Mac, and don't forget to include those screenshots. If you have any questions, be sure to let me know.